The pneumatic system uses hot, compressed bleed air from both engines to operate the air conditioning packs and the wing and engine de-icing systems. There's a dedicated system of isolation valves and leak sensors to regulate airflow and protect the aircraft in the event of malfunctions in the pneumatic system. Controls for operation of the pneumatic system are on the overhead air bleed panel. Indications are provided on both the air bleed panel and the system display cabin page. Maintenance controls and indicators for testing the pneumatic duct and monitoring system are located on the lateral maintenance panel on the first officer's side. The primary ducting for the pneumatic system bleed air is from each engine down to the packs, which are located in the wheel fairings. Bleed air is also ducted to the wing and tail leading edges for the airframe and engine de-icing system. And finally, there's a small amount of bleed air ducted back to both outflow valves for their pneumatic operation. Bleed air for the pneumatic system is taken from the engine compressors. The primary source of this bleed air is the low-pressure compressor. This low-pressure supply is sufficient for most phases of flight. If low-pressure stage is insufficient, air source is automatically switched to the high compressor stage. Pneumatic bleed air must maintain a minimum pressure output to operate the packs. Therefore, during periods of low engine RPM, ground taxi, or idle power in flight, the engine low-pressure compressor cannot maintain adequate pressure. So, to provide the required pressure, a high-pressure valve will supply the bleed air. For any power setting, a high-pressure air is always at a higher pressure than low-pressure air. The high-pressure valve is closed when high-pressure air is not required for the packs. The high-pressure valve opens automatically during low RPM to provide the necessary air pressure. There are no direct controls or indicators for high-pressure valve operation. While the high-pressure air is supplied to the packs, the low-pressure air is not supplied. Some of the high-pressure air flows directly to operate the airframe de-ice system. Therefore, the airframe de-ice system never receives low-pressure compressor air. This de-ice airflow to the airframe is described in the ice protection modules. There's also a primary bleed shutoff valve on each side. These valves, labeled Engine 1 bleed and Engine 2 bleed, are electrically controlled but pneumatically operated. If there's no pneumatic pressure, the valve is spring-loaded closed and cannot open. Note, with loss of electrical power, the de-energized electrical solenoid locks the valve closed. Normally, the bleed air from each engine is dedicated to operating the respective pack. There's a ground crossfeed valve between the two systems that is automatically operated and is normally closed. On the ground, when the right engine is operating in the hotel mode or during single-engine taxi, the ground crossfeed valve opens to allow bleed air from the right engine to also operate the left pack. When the ground crossfeed valve is open, the amber crossfeed valve open light is displayed. The only controls for the pneumatic system operation are the two engine bleed push buttons. During the cockpit preparation procedures, the flight crew will verify that both engine bleed push buttons are pushed in with the white off light extinguished. All bleed air system operation is automatic. Pneumatic system indications are displayed in two places: the overhead air bleed panel and the cabin system display. The air bleed panel has green lines that represent the air in the bleed crossfeed pipe and three available symbols to display the bleed crossfeed valve position. The panel also contains amber lights to indicate overheat or leak conditions, as well as the crossfeed valve open light that displays the ground crossfeed valve status. The two pack valve push buttons control the bleed air supply to the packs and will be discussed in the air conditioning module. The System Display Cabin page displays animated symbols for duct and valve operations, and it also displays messages corresponding to the illuminated lights on the overhead panel. Normally, the only pneumatic ducting displayed is between the engine and the pack valve. However, when the ground crossfeed valve is open, the crossfeed indication, pipe and valve, are also displayed. Let's look more closely at the two bleed push buttons. The white off light is an indication of push button position. It goes out when the push button is pushed in. The amber fault light is a disagreement light. It illuminates when the valve position disagrees with the push button position. On the System Display Cabin page, when the bleed push button is off, the valve symbol displays the closed valve, and the white message bleed off is displayed just inboard of the bleed valve symbol. During our pre-flight cockpit preparation, we would verify both of these push buttons are pressed in and the white off lights extinguished. Now, press both push buttons on and observe the effect. The bleed push buttons are now on, and the off lights are extinguished. The amber fault light in each push button is now illuminated. This is normal. Because the engines are not running, there's no pneumatic pressure. Therefore, the bleed valves cannot operate. On the System Display Cabin page, the white bleed off message blanks, the amber bleed fault message displays, and the closed valve symbol now displays amber as well. The next pneumatic system event occurs when the right engine is started with the prop brake on, hotel mode. As we start the engine, notice what happens to the pneumatic system when duct pressure is available. On the panel, the amber fault light in the engine tube bleed push button extinguishes, and on